Yeah.
Right.
No, that's super interesting. And yeah, it's a great reflection that because
Mhm.
I don't recall when we were talking, Damian, about this regarding like load testing and peak kind of things for example, retailers like with these Black Fridays,
Mhm.
Christmas events, and this is something that definitely needs to be evaluated before
This
considering a
is
repatriation.
this is an interesting example. First time I think we talk about taxes and
Yeah, yeah,
but
yeah,
no,
yeah.
nobody wants to
And it's
pay
interesting.
taxes. Of course, they will leave it to the last day. But
Yeah,
uh, but yes, elasticity is a good example of how the cloud can help you. And of course, if you want to move that into the on-prem, of course, always want to need the hardware to be supporting on your top on the the worst performance, let's say, right? So you're wasting a lot of money.
yeah.
And of course, I think the on-premise we talk in this show several times about the clarity, the clarity
Hmm.
that the cloud offers you, and I'm not sure you can even get to the point of that clarity on the cost clarity, right?
Yeah,
On-premise, there's a lot of
yeah.
ways that you don't know, right?
Yeah, and there's also surprises, right? When you have an on-premise workload, the data transfer is free, right? But you
Mhm.
move into the cloud, all of a sudden you need to pay for the data transfer. So if you had a noisy communication protocol, then you may saturate your data transfer charges in the cloud. And that is a common thing that I see when people migrate, that they sort of forget about certain things, right? Some of the virtual machines, they don't come with storage, with
Mhm.
disk storage, right? Or virtual disk storage. So you buy the virtual machine, but you can't run an operating system on it because it does not have ephemeral storage. So you need to attach elastic block storage, and that has also an additional cost, right? So that is another common mistake that I see that engineers do when they size workloads in the cloud, right? That they forget those things.
Yeah. And moving on to that topic, like, what are your recommendations when you have to do an exercise of sizing workloads in the cloud? Like, what do you recommend? Because I'm sure you have done a lot of sizing and estimation exercises. So, what are your main recommendations for doing that kind of things?
That may sound weird, but one of the best things to get your engineers to provide high quality work or deliverables in the cloud is to ask for a certain percentage of your engineers to be certified.
Hmm.
It gets, at Intuit, we had to mandate that 50% of the engineers need to get any AWS certification, right? It doesn't matter if it was professional, associate, specialist, or those kind of things, right? Just because, once you have enough certified engineers in the team, it will cross-pollinate, right? Like an uncertified team member can ask the certified team member for advice, right? And it's really the knowledge that is driving the quality of the work, in my experience, right? And it sounds a little bit barbaric that you just mandate 50% get certified, right? But it helps the engineers, right? They are more employable with their
Hmm.
next employer, right? And they are uh, able to help, and they know when they need help, right? And all these cloud vendors, maybe except for Azure, right? They are very welcoming to provide solution architects for projects, right? Have that person sit with your team for like 2, 3 weeks and provide advice and insights into best practices, well architected framework, and those kind of things.
No, that's very interesting. I haven't thought about that on because in my company there is definitely some incentives on do that. I know that there are companies that even give bonuses to people that get certified. So there are different programs that are interesting in that topic.
No, no,
Yeah, bonuses is definitely better than layoffs.
No, for sure,
I
for sure.
Definitely. Also, I, it might be when I was learning and learning, all the time there are new things, and when you do the certificates or recertifications, you always found out there were new things that were going on, and new optimization or another key features that might help you in optimizing or helping the workflow, not only on the economic level, but also
Yeah.
on the efficiency, right? When you work efficient, in any case, you know the pillars, or any pillars that you choose will help you eventually economically.
Yeah, exactly, exactly. And this is where well-architected comes into play, right? Every cloud vendor has something that it provides best practices and guidelines on how to work in the cloud, how to build things in the cloud.
Totally. And regarding this skill set or this training and educational level, what do you think are the skills or the education that someone can get to become a good FinOps practitioner, especially here from the technical perspective, because we here are both coming from the cloud world. But from that side, what are your recommendations on formation and education and skill sets?
That is a very good and interesting question because the engineers, they know how to write code, right?
Yeah.
And that includes things like even how to use a GitHub or GitLab, right? How to use libraries, right? A lot of the code uses public open source libraries, right? Which are maintained outside of your organization, right? And could have a security risk with them, right?
Yeah.
We just recently had a situation of a Linux compression command line tool that had a vulnerability exposed on purpose, right? So and then the engineers are also familiar with other tools like PagerDuty, for example, right? So
Yeah.
that they can integrate with that. And observability tools, right? Like a Datadog, Splunk, New Relic, those kind of things, right? So the engineering skill set is not just really focused on writing code, right? But there's all these other systems that they need to become quite proficient in, right? And I would say that the cloud is yet another system that they have to become proficient in, right? And
Hmm.
as I said, there's over 175 products when I checked the last time. And just in Amazon Web Services, the same is true for Google Cloud, the same is true for Azure Cloud, right?
Yeah.
And depending on where that engineer is working, they need to know maybe a dozen, 2 dozen services and need to be familiar with them quite inside out, right? Quite
Hmm.
know the details. So, for example, a virtual machine on AWS works differently from a virtual machine on Google Cloud, right? Google Cloud is much more fungible when it comes to CPU and memory, while AWS has certain slots that you can get, right? And then there's also differences with additional ancillary services, right? Like the simple storage service on AWS and the lifecycle management and then on just Google Storage, cloud storage, right? Um,
Hmm.
for example, on the AWS side, when you have an aged out object that is aged to colder, less expensive storage, right? It gets rehydrated into a staging area, right? While on Google Cloud storage, the object is available instantaneously. However, the aging out is a 365-day time period, right? So as you access an older object, it is available within 10, 15 milliseconds. However, you have to pay for it to age out again, right? While on
Yeah.
the AWS side, it may take some time to rehydrate, and then it stays within that staging area for 30 days, after which it gets cleaned out. So the engineers really need to understand all those intricacies, right? When you look at Elastic Block Store on the AWS side, there is GP2 and GP3 options, right? Now you can switch between GP2 and GP3. However, many engineers are not aware that there is a cool down period of 4 hours for switching back. So while the switch is in most cases seamless, right, and it can be done online, you don't have to take the volume offline. If you decide to make any other changes, you need to wait 4 hours before these can be applied. So the engineers really need to understand how these cloud services work, or you will get surprises, right? For example, we had a situation where an engineer used a Terraform script to instantiate a vendor solution. It was in a sense a SaaS solution that was self-hosted, right?
Mm-hmm.
And whenever they had a configuration error, they just tore down the cloud workload and instantiated it again. And they did that, 20, 30, 40 times. What they didn't realize is that they started orphaning those elastic block store volumes, those virtual disk volumes, and that kept, because the entire system was supposed to be a SaaS solution. So I think the volume was like 2 terabytes in size. And they had, after a month of trying to install that software, they had like, 160 terabytes of orphaned volumes lying around that they were simply not aware of, because from their point of view, they were just running a Terraform script.
Yeah, they are not dealing with the consequences of doing that. Yeah, definitely.
Exactly.
No, that's an interesting use case, and I do agree that for doing optimizations and for doing FinOps work, you definitely need to know inside out the cloud services. I, for example, and I talk with Damian and with the people that we talk about that, for example, I am much better in GCP than in AWS, and it translates only in the generalistics, like
Yes.
system designs, cloud knowledge a bit. But then when you are actually using the tools, the proficiency that you have on the day-to-day basis is nothing compared when you are used to do a work with a provider all day for every day in your work life. Then, for example, if I now have to switch to AWS on a day-to-day, I will have to stay rolling, and then if I am on GCP, I am super comfortable. It's I totally on that point.